All right, let's proceed to question number 3, and it has been derived from the topic prism, ray optics. An isosceles prism is there whose angle of prism is A. These two angles are of course equal. The refractive index is mu, and it's also given that for this particular prism the minimum deviation is equal to the angle of prism. Before going to other option, what we'll do is that on the basis of this particular fact, let's see what information can be extracted. A very common relation, that is mu equals to sine A plus delta m by 2 upon sine A by 2. That's a condition at minimum deviation. Delta m is given to be A. So plugging that would be sine A, and straightforward that will be 2 cos A by 2. That's a very straightforward relationship. Now here what we get is, say, on the basis of that fact, I can easily say option number D would be incorrect. That's a very clear cut there. The factor of half and 2 is there. Now let's go for option number A, B and C. For option number A, it says the emergent ray at second surface will be tangential. So the condition is something like this. The emergent ray at the second surface is tangential. So let me make the figure something like this, and here it goes tangential. Let's draw the normal. And under this particular condition, I am asked to calculate I1, the angle of incidence at the first surface. So this is I1. Well, this is 90, so quite obviously this would be theta c, no prize for guessing. This is A, and this plus this is equal to A, so that angle would be A minus of theta c. Now all I have to do is that I need to apply Snell's law between these two particular angles, and that would be 1 sine I1 is mu sine A minus theta c. No more concept beyond it. All you have to do is you have to rope in the value of mu here and open up this particular thing, and when you solve it, that's a slight bit of trigonometry, you will get option number A to be correct. Let's go for this. For I1 equals to A, ray inside is parallel to the base. Try to recollect. When the ray inside is parallel to the base for isosceles prism, it's a condition of minimum deviation. So in that situation, the minimum deviation condition would be straightway this, this and this, all the symmetric condition, and that angle would be equals to A by 2. And I need to calculate I1. So here is I1. So I'll be getting 1 sine I1 is mu sine A by 2. Plug the value of mu that had been calculated here, and that would straightforward give you option number B to be the correct option. Option number C, at minimum deviation R1 is I1 by 2. Well, that's fine now, because option number B says at minimum deviation I1 is A, and this is always A by 2 at minimum deviation. So for this specific condition, option number C comes out to be correct. So for this third question, the correct option would be A, B and C. These are the correct option. That was for question number 3. Now it's time to move for question number 4.